Black math! Give me some math and I'll give you some flack. Black math!
All right, you ready? Let's start with number 1. Anybody do the practice test who didn't upload it yet?
No, I'm sorry. I haven't watched
Okay,
school.
I guess Tori gets 10 points again.
I'm so proud of her. She's really on top of it.
What's wrong with you guys?
Wait, I got like
Come on now.
Very smart.
I love
I
Tori
appreciate it.
with all my
Did you
heart.
do a practice test? Anybody?
Do you have a pen? That's number 7.
What?
Do someone else.
No. Ava.
Never mind. I'm glad I have some right there.
You get it to be there.
No, I'm all good. Can I draw on your hand? I don't know. Mine is like out of room at this point. Okay, hold on. Let's do it.
Can I use my Flack attack card for 5 points?
Wait, I'm gonna try and find a black pen. Hold on.
All right, let's do it. What did you say? Flack attack what? Oop,
Can I use
blah,
my Flack attack card?
for a practice test?
Yeah.
Yeah, but that's a waste because I'm gonna do it for you right now.
No, but like 5 points.
Oh no.
Well, it's worth a try.
Okay, number 1. A landscape architect is designing a garden in the shape of a rectangular hexagon. A regular hexagon. Rectangular hexagon doesn't make sense. Okay, so here's what it looks like. Yep, I'm awesome. That looks good. Okay, so that's a regular hexagon. The side lengths of the garden measure 7. So since it's regular, they're all 7s, right? Side length of a garden 7 on a blueprint with a scale of 1 inch is 5 feet. Okay, how many feet of fencing will be needed to surround? So I need to find the perimeter, but this is the blueprint where it's 7 inches on the blueprint. Okay, so remember, for every 1 inch on the blueprint, it's 5 feet in real life. So what's the perimeter? How do you figure out the perimeter?
You add all the 7s together.
Okay,
So it would be, is that 7 times 7 or 7 times 6? It would be 6. 42.
yeah, so
I was
42
gonna
inches.
say-
Okay, but that's not the perimeter, is it?
Wait,
What's the perimeter of the garden?
42 inches.
Okay, now that you have your paper out and are listening, no offense. Remember, this is just the blueprints. It's 42 inches on the blueprints. But the blueprints say for every 1 inch on the blueprint, it's 5 feet in real life. So now how do you figure out the perimeter?
7 times 5, and then you
Then
do
you
it.
add them. Or you can do what?
42 times 5.
42 times 5.
And
Okay.
that is 42 plus 42
All right.
is
Thank you for raising your hand, but wait till I call on you. Because you did raise your hand, but you answered when you.
I'm sorry. I'm so sorry,
I know,
Tyler. If
you're
gonna
excited.
call you, I'm so
Math
sorry.
does that to people. So what is that? 210 feet? Is that what you guys got?
Yeah.
Oh, that's right. You didn't do it yet.
I did.
Did you?
I didn't do it. I did it
Oh,
before you did it, but
Yeah.
I didn't do it before class.
Okay. All right. Number dos. That means 2. Okay.
Whoa.
That's right. Find.
Oh, do you know what Vente Uno is?
Yeah, 21.
Oh, wow.
Now do it in German.
I don't know German.
Eins,
Okay.
zwei. Ah!
Yo, asked for it.
He did it.
Yeah. No,
He did say
I'm not going to
slide.
shut up.
Well, I said 1, 2.
Yeah, eins, zwei, drei, vier.
Do you know what
So on, so
escuela is?
I mean, you deserve the
School.
Dang.
I did live in Nicaragua for more than a
You
year.
didn't.
Yes, you did.
Yes, I did.
I did not know
I
that.
feel like Italians are the loudest than Germans.
Scary.
Okay, so here's the diagram. Find OYX. Okay, if you guys don't know how to read or write an angle yet, listen up. OYX, the vertex is in the middle, so it starts at O. Take your finger and go to Y and then X. So this is the angle in question. We want to know what this angle is. What does it look like? 90-degree angle. So that's the measure of it. But If you can tell me why, that would be cool. So there is a theorem that if a diameter bisects a chord, then it is perpendicular to that chord. Okay? There is a theorem somewhere in there. I'm not going to tell you where because that's extra credit. But the measure is 90 degrees. Any questions? Okay. Number trace. You don't pronounce it like that. I'm just saying it because I'm German.
Wait, is that a two?
Einstein. Is that right?
Nice fight. Yeah, it's right.
Wait.
Right.
Who knows?
Try.
You know German?
Yeah.
What's 21?
Why?
I just want to know.
Hold on. I don't know it off the part. I would have to come it.
Okay, triangular is equal angular. So all the angles are the same, which means all the sides are the same. That's right. Okay. So that's the only when a triangle is equal angular, then it's equilateral. But that's not the case for like a square or a quadrilateral, like because it could be a rhombus or a rectangle. A rectangle is equal angular, but not equilateral. Okay. Some of you don't know what equal angular means yet. It literally means equal angles. Okay. And equilateral, lateral means sides. All right, a triangle is equal angular. It has a perimeter of 16.5. Determine the length of each side. So all of these have to be the same. So how do you find the length of one side if you know the perimeter? Divided by 3. 16.5 divided by 3 is 5.5. So 5.5 inches. Does that make sense? All right. You don't have to draw it out, but drawing it out kind of helps you connect with it on a personal level. Okay? I feel like we know each other way more now.
Wait. Is that long division?
Yeah, I did long division. You don't have to. You
Wow,
can use your
blast
calculator.
from the past, alright?
Dirty monkey smell bad, baby. All right, number 4. Order the measures of the angles. Okay, this is where you guys got confused. Order the measure of the angles, and you gave me sides. No, it looks for the measure of the. How do you say these angles? What's the smallest angle? Well, what does your gut tell you? What's the smallest angle? You could just use one letter, right? Because there's no other angles connected to those. What's the smallest angle, Kate?
G,
Nope.
R.
Did you say P and then R?
Well,
Yeah,
I said, which one is right?
that's the Q.
Because I said G.
Oh yeah, so that's not a G, it's a Q.
Oh.
So Q is right. Okay, so the other way you can know for sure is that the opposite side is 12, which is the shortest leg. So if it's opposite from the shortest leg, then it's the smallest angle. Makes sense? It's pretty logical. Okay, so what comes next? What's the next smallest angle? Not P, because R is across from 19 and P is across from 20. Do you see that? So it's got to be R next. Does that make sense to everybody? Because it opens up farther. See how P has to open up farther to get the 20 feet. So that angle is going to be bigger than the angle R, which only has to open up to 19 feet. Okay? Make sense? All right, number 5. Draw a pentagonal prism in 1-point perspective. Okay, this doesn't have to be great looking, but I mean, come on, let's do it. Let's make it great by using a ruler. So you can draw any kind of draw a pentagonal prism. All right, so this is.
Whoa. That was a lot of this is.
Pentagonal prism in 1 point perspective. Okay, so we're going to draw a pentagon. Let's see here. Let's see here. Let's just draw a pentagon. So here's the deal. Wait. How did they do this? How did they do this? In 1 point perspective. Okay, so I'm thinking. Okay.
You're still on 5.
All right, so here's what you just need to do. You just need to draw a pentagon, okay? And then you need to draw a point, okay? Draw a pentagon, draw a point, connect the points. Connect the point to all the vertices. Blip, blip,
Wait,
blip,
this take you so long?
blip,
Because sometimes it's hard to figure out.
blip, okay? Then all you're doing is just drawing, you just got to draw the other end somewhere. So if I do this, make sure all that's parallel.
Whoa, what is up with
Okay, so that's going to go.
Mine looks just like yours. I'm so proud.
Wait,
Okay,
I don't know how to draw it.
and then you can erase that for extra coolness. You can probably erase this inside, these inside lines here for extra coolness.
Wait, we have to. Oh, I did it. As a purpose.
Okay, that's what a pentagonal prism, you don't need to have those lines in there, and you don't need to erase anything. But that's what a pentagonal prism with the 1 point perspective looks like. Okay, that's pretty cool. All right, we're 5 done. We're 25% done. Moving on to number 6. Given the two triangles, the values as shown below show that they are similar triangles. How do you show that triangles are similar?
What?
How do you show that triangles are similar?
Scale factor.
Scale factor, okay.
Um,
There is a scale factor, but there's an easier way. What?
They look similar.
This number over this number
Yep.
equals that number.
What's that called? Starts with a P.
It's not
Perimeter?
the Pythagorean theorem.
Proportions, right?
Yeah.
So I can go like, for example, it looks like BC and EF. BC is to EF as
A is to D.
ED, no, A is a point. So that, a point doesn't have length. You have to give me a line segment. So ED, so BC is to EF, so 8 is to 16. As let's see, 14 is to 28, so that's AB is to DE. Okay, and then CA is to FD. So 10 is to 20. Okay, I will take either of these answers, but make sure you line up the right numbers with the right numbers or the right line segments with the right line segments. Okay, if you don't, it's not right. Okay, you got to show me that, oh, yeah, BC is to EF because 8 is to 16, as AB is to DE. Oh, it's 14 is to 28. Yep, that's 1 to 2, 1 to 2 if you reduce that. Okay. You could also show me with scale factor too. You could say that EF equals 2 times BC, or BC equals 1/2 EF. That's fine, but do it with all three sides. Okay?
Is that 6 or is that still 5?
What?
That problem.
Oh, this is number 6.
Sorry, I got confused.
Okay, so number 7, find the arc length of the circle with radius 12 centimeters. So radius of 12 of xy, and the measure of xy, the arc measure is 30 degrees. So let's see, xy, if this is 30 degrees, I want to find the arc length. You guys understand the difference between arc measure and arc length? Measure is just degrees, but this is actually how many centimeters it is, right? Degrees aren't centimeters. So how do you figure out how many centimeters this arc XY is? How do you do that? So you don't have to be mathy. Just explain to me how I figure out just that part of the circle. I don't want the whole circle. I just want that part of the circle. So in non-mathy terms, can you explain it, or mathy terms? Do you know?
Yeah.
Okay.
I mean, I know a way, but
Okay, how would you do it?
I know a long way. You would find that like just the entire circle and then divide it by 30, or like 30 over 360.
Yeah, so not dividing by 30,
Yeah.
but it's only 30 out of the 360 degrees that you want. So that fraction, or basically it's 1/12, right? But if you find, how do you find the circumference of the whole circle? How do you find the circumference? Pi times diameter, right? Remember that? Circumference equals, but you don't want the whole circle. You just want this fraction of it, 30 out of 360. Okay, so you just want this fraction, which is just 30 out of the 360, or 1/12 if you reduce that. Okay? You guys remember finding semicircles? You found the whole circle and you divided by 2. Same thing here. And I mean, that's what you're just going 180 out of 360, which is 1/2. So this is just 1/12. 30 is not 1/2 of the circle, but only 1/12 of the circle. So if this was a pizza, there'd be 12 pieces in that pizza. Okay, now I'm hungry. So this is 1/12. You don't have to reduce this. You can just do all this on the calculator.
6.28.
So so you're multiplying to find the circumference of that thing. It's 24 times pi, right? Pi times diameter. The radius is 12, so the diameter is 24. So pi times 24 is just 24 pi. And then you can do some reducing if you want, or you can just multiply across, whatever. So this is just 2 pi. That's the length of that. Now, what does it say? Give your answer in terms of pi. That's it. So don't multiply by 3.14. Leave it in terms of pi. So it's like that variable that you're stuck with. Okay? That makes sense, because if the whole circle is 24 pi, this is only 1/12 of 24 pi. Okay? Can you guys handle something like that? Here's the easy way. If you want to just take your brain out of it, it's this measurement over 360 times circumference. Circumference, and you can write this down and use this on the test, is just pi times diameter. If they only give you the radius, you have to double it, find the diameter. So it's this number over 360 times 24 pi. So you can just multiply all that out. You don't even have to reduce that. 30 times 24 is 720 divided by 360 is 2. Still get 2 pi. Okay? That's number 7. Number 8. Okay, polyhedron. So how many faces does a polyhedron with 5 vertices and 6 edges have? There's a formula. Remember who made this formula? You remember, Tobin?
Yes, it's Euler.
Euler. Remember, Euler. Does anyone remember that formula?
Did I say it loud enough this time?
Yes. Euler's formula. What's Euler's formula?
N minus 2? Wait, no. N minus 2 times 1.
No, so that is actually finding out how many, like what all the interior angles in a polygon adds up to. Okay? Anyone know Euler's formula? Because I don't.
I should.
Let's look it up. Sorry, I usually have my.
It's F minus E plus. Is that right?
Okay, it is not that.
It's like F minus E plus something else, I think.
All right, so here's the formula. V plus F minus E equals 2. V plus F minus E equals 2. So we're going to plug in what they gave us. So write that down, use it when you take your test. V plus F minus E equals 2. So do they give us V? Yep, 5 vertices, right? So I'm going to put in 5 for V. Do they give us faces? Nope. Do they give us S edges? Yep. 8 equals 2. So what does F have to be? Can you do that in your head?
5. Sorry, I should have raised my hand.
5 faces, right? 5 plus 5 is 10 minus 8 equals 2. Okay? So write down that formula. Don't forget it like I did.
Wait, what's the bottom thing?
5 plus F.
5 equals F. Sorry, thank you.
Vertices.
Okay. All right. Number 9 and 10. Here we go.
Wait, Mr. Flack,
Uh-huh.
what does V stand for again?
Vertices. Yep.
Sounds right.
So it's going to give you 2 out of these 3 variables. So all you have to do is plug them in and then figure out the third. Pretty easy. If you can remember the formula. Number 9. Here we go. Find AD. All right, this is one of those special dealies, right? Find AD and AB in the diagram below. Okay, so if this is 10, we know that this is perpendicular. So when this is perpendicular, that means it creates 3 similar triangles. You got the big guy, you got this little guy here. So if you rotated it and expanded it, it would be that triangle. And then this one, if you turn it around, it would be that triangle. See how there's a big, medium, and small? Do you guys see those 3 triangles? Those are all similar triangles. So if this is 10, this is 8, and this is, well, that's 6 and that's 8. Okay. That's nice because look, this 10 goes with this short side. So 10 is to 8 as 6 is to, let's see, that's the hypotenuse. So this would have to be X. So let's find X there. Or really this is, let's just put our variables in there, A, B, C. 6 is to AB. Okay, so do you see how I connected that? So this is the short side of that triangle, 8. This is, no, I did that wrong. 10 is not to 8. That's the hypotenuse of that triangle. Oh, wait, no, 10 is to 8. Because of the big triangle, that's the short leg of the big triangle, right? Short leg of the big triangle. And then 8 is the short leg of this medium triangle. 6 is the short leg of the small triangle. Oh, so it wouldn't be AB. This is embarrassing. Okay, so that is there. So let's go to 6. 6 is the short leg of the small triangle. Is to, well, no, that should all be there together. Sorry. So let's go with the hypotenuse of the small triangle. Is to the short leg of that. Okay, so no.
So let's just say we skip this one.
No.
Make it extra credit.
You got it.
No, we got it. I'm just backwards here. So here's what would be nice. And this is a good reason to do this. So you got your small triangle, which it looks like this. 6, 8, 10. You got your medium triangle, which is, let's see, that's 8. And then we got this business, which we don't know. And then your hypotenuse of that, you don't know. And then you got your large triangle, which is just 10. And then don't know. Okay, so let's figure out one by one. So we can say 10 is to 8, as that is to that. Well, that's not going to help me. So let's go 10 is to 6 is to 8. I'm going to put variables in here. So X, Y, Z. So 6 is to 8 as 10 is to Y. Okay? So that is going to be a fraction, but okay. 80 divided by 6, 40 divided by 3, which is 40/3. Okay, so Y equals 40/3. With Y in this case would be AB. So AB equals 40/3. What is it asking for? Find AD and AB. Okay, so AD is, let's see, AD is right here, this guy. So it's the short leg. So that's X. Okay, well, we can do that because now we know that's 8. So we can go 8 is to 6. 8 is to 6 as X is to 8. So X has to be 6. No, X does not equal 6. It's 64 divided by 6, which is 32/3. So AD equals 32/3. All right, do you want me to make this extra credit?
Yeah.
Okay. It's a lot of similar triangles. I would suggest drawing it all out. That'll make it easier. There's also some shortcuts. If you go to that lesson, there's some shortcuts that give you the actual mathematical calculations, okay? Number 10. Write an indirect proof to prove theorem 39(2). This is also extra credit, okay? Here's the thing with extra credit. Each point, since there's 20 questions, how much percent is one question? 5%, okay? So if I take away 2 problems, then I'm giving you 10 points. That's pretty good. And they're also extra credit. Okay, so you're welcome, I guess. So we're skipping 10. You can do that for extra credit if you like. Number 11.
I don't even know how to do it.
Well, luckily it says go to lesson 48 and figure it out. Do you want me to tell you how I would do the number 10?
Yes.
Okay. Indirect proof means assume it's false and then provide a counterexample to prove yourself wrong. Indirect proof, 39(2). Here's what 39(2) says. One angle of a triangle is larger than another angle. Then the side opposite the first angle is longer than the side opposite the second angle. Okay, so for example,
Wait, isn't this 11 though? Or is this?
this is 10.
Oh.
So if this is A, and this is B, and this is X, and this is Y. So we're saying if angle A is bigger than angle B, then X is going to be longer than Y. So let's say that this is not longer. So England prove that BC is greater than. So let's assume that this is not longer, that this is shorter than that side. Then that goes against a theorem that you have to find that says that the a triangle's sides correspond with their opposite angle measures. Okay, so if you look in lesson 48, that's going to talk to you about indirect proofs. But lesson 39 is where you see this theorem, where they actually prove it using the theorem that you want. Okay, so you have to dig for the right theorem if you want to do it. Okay.
Can we look in our books on tests?
Yep. All right, number 11. A rectangular frame is divided by two diagonal edges. Okay, this is a gut problem. That means you're going to use your gut. If PI, which is right here, here's I. If PI equals 5 inches, then you could probably figure out what the rest of the stuff is, QR. So if this is 5 inches, what's the rest of this going to be? 5 inches. 5 inches. So what's QR? 10 inches. Right? If that's 5 inches, that's going to be 5 inches because in a rectangle, the diagonals bisect each other. So that means these are going to be the same and these are going to be the same. So use your gut on that. All right?
Wait, what's that letter? PQR what? Is that S?
That's an I. So PQRS and then I is in the middle. So does that make sense? If that one is 5, then they're all going to be 5. Doesn't it look like 5? They're all 5. So QR is just 5 plus 5, which is 10. All right, number 12. Find the distance from point. So you can use the distance formula or you can graph this. Oh, no. So it's the perpendicular distance. So I would graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Here's point P. Is 5, 7. Some of you on the last test went over 7, up 5, or up 5 over 7. Don't do that. Go left or right first, and then up or down. All right, now, where's line x equals 8? Where's line x equals 8 on a coordinate plane? How do you draw a line x equals 8? Come on.
Sorry.
How do you draw a line x equals 8?
It's just the entire line.
Okay, does anyone besides Tobin know that? You need to know that. When it's x equals something, it's just a vertical line where that something is. So how do you draw the line x equals elephant? You go find elephant on the x-axis, and you draw a vertical line through that. Okay, so x equals 8. 1, 2, 3, 4, 5, 6, 7, 8. This is what it is. How many units is this point away from that line? 3. You go from 5, which is where this is, over 1, 2, 3. 3 units. Can you guys handle that problem? All right, using the diagram below, find QR if PS equals 18, RS equals 6, and PQ equals 16. All right, there are some relationships here. So if that's an angle bisector, then it's going to divide so it doesn't matter if these are angle bisectors, then it's going to make these opposite sides of those angles the same. Okay, so I drew it like this, obviously different. just so you can kind of tell. So if this is P, Q, R, PS is 18, RS is 6. Where's S? Oh, PS is 18. Here's S. RS is 6. PQ equals 16. So you have to find QR. Well, if this is 6, then this whole thing is going to be 12. Okay? All right, that was number 13.
Wait, what were we supposed to put?
You're trying to find QR, which is that whole distance. So if that's 6, that has to be 6. So the whole thing is 12. Okay, 14 and 15. In the diagram. FG is a mid-segment of the triangle. That means these have to be the same. All these are the same. Mid-segment, that's what a mid-segment does. It bisects those line segments. So if this is 6, then this is 6. And then these two, we're not given those. Okay, but if this is 9, remember this is going to be 18 because it's twice the length. When you have a mid-segment, that line is twice the length. So x equals 18. Everybody got that? Again, use your gut. Well, it's halfway to the bottom. So that means the bottom is going to be twice as long as that line there. Okay? Now what's y? Well, y is 6. Because that's what a midsegment does. Is it goes from midpoint to midpoint. So if F is the midpoint of DC, then it's going to separate DC into 2 equal segments, 6 and 6. Everybody got 14? All right, 15. Triangle ABC. A is at 0, 0. B is at 4, 0. So over 4, up 0. C is at 2, 5. So over 2, up 5. So there's ABC. Use a coordinate proof to show that triangle ABC is an isosceles triangle. Well, it looks isosceles, doesn't it?
Can't you just distance formula?
Yep, you can use the distance formula. So the distance of AC equals the square root of, let's see, use the distance formula. AC, so 0 minus 2, parentheses squared, plus 0 minus 5, parentheses squared, equals the square root of 4 plus 25 square root of 29. So just leave it like that. So the distance of BC equals, well, the distance between B and C, let's subtract B minus C, or B minus, so 4 minus 2, parentheses squared, plus 0 minus 5, parentheses squared, also is 2 squared plus 5 squared, which is the square root of 29. Check. You just proved that those two sides are the same, so it's an isosceles triangle. So you need to prove that these two are the same. To prove with a coordinate proof, find the distance of those two line segments. Okay, home stretch, 16 through 20.
Oh, wait, I'm not done with 15.
Okay, I won't erase it. Okay, 16. A movie theater sells tickets for children, adults, and senior citizens. The theater gives discounts on all children and senior citizens. Consider the statement: a customer and is a senior citizen, and a customer gets a discount. What is the conjunction of these statements? Okay, use a truth table to assess its truth. Okay, so a conjunction. If a customer is a senior citizen, then the customer gets a discount. Okay, if you want to do a truth table, you can. I'm going to make that part extra credit. Okay. Remember that if you do the if and then you have to decide whether it's true or not. So remember, when the if is false, then the truth table is true because there's no way to know. So if you want to do that for extra credit, you can look back at lesson 20 and figure out how to put together that truth table, but you still just need to combine, make a conditional statement out of that, okay? Number 17, find the measures of 1, 2, and 3. Okay. Challenge accepted. One, 2, 3. You don't know if there's right triangles or anything. You don't know. It looks like a right triangle, but you can't assume that. The only thing you know is that this is 122 degrees from here to here. Okay? So what does that tell you? And the other thing you know is that that goes through the center. Okay? So if that's 122 degrees, then what's the measure of angle 3? You guys remember how to figure that out? If this is 122 degrees, which is the arc that angle 3 intersects, how do you figure out angle 3?
Would you have to subtract 360?
Nope. How do you find angle 3? So ignore everything else. Just pretend that angle 3 is just in that circle. How do you find the measure of angle 3 if it intersects this 122 degree arc? Do you remember? Okay, write it down. Tell us how to do it, Tobin.
Would it not be half?
It's just half. Okay? If this was a central angle, then it'd be equal to that angle. But this is an inscribed angle. So measure of angle 3 equals 122 divided by 2, which is 61 degrees. So far, so good? All right. So that's 61 degrees. Can you figure out the rest? Remember, we can't assume that that's a right angle. Angle 2 looks like a right angle, but we can't assume that. But what do we know? Can you see it? Took me a second to find it. So this is all we have so far.
I mean, wait, so you can.
Anybody see it? Any guesses?
Maybe? Is it up there on top?
Well, this is 122 degrees here. So we need, if we can figure out these arcs, then we can figure out those angles, right? You just divide those arcs by 2. Okay, but can you figure out what any of these other 2 arcs are? Can you see it? Chili, you keep having revelations.
I see it. Oh, I see it. Okay.
Do you want to guess? Take a guess.
What are we trying to do?
We're trying to figure out the measures of these arcs.
I see.
Because if we can figure out the measures of the arcs, then we just have to divide them by 2 to get the angles, right? Because 1 is right across from this little arc, 2 is across from this arc. Want me to give you a hint? What's this dot mean? That's the center. So what is this line? Diameter. So what's this arc? If this is the diameter, what's the measure of this arc? What?
Is it 61 plus 61?
No.
Okay.
But good job for sticking your neck out there. Guys, what does a diameter do to a circle?
It's in that.
It cuts it in half. So what's the measure of this arc?
It's just 122 plus.
No, you're too much math. What's the measure of this arc if this is
Oh, 180.
180? Okay, like I said, it took me a while to get there. Oh yeah, that's a diameter. So it cuts it in half. Okay, so if this is 180, Maddie, how do you figure out this? What's left over? Subtract 360 minus all that, right? So what's the measure of angle 2? If this is 180, what's the measure of this angle, this inscribed angle? We just went over it. Don't fail me now. Don't fail your test tomorrow. 90, it's 1/2 of that. So now it is, now we know for sure that it is a 90-degree angle. So now at this point, we can forget subtracting from 360 and we can just use the 180 rule on the triangles. So this is 180 divided by 2, which is 90. So what is measure of angle 1? Well, what would that be? 29 degrees, right? Because they all have to add up to 180. So that means this arc has to be 58 degrees. So what's 58 plus 122 plus 180? 360. Okay. So there's a couple different ways to get there, but this is a puzzle. You have to see beyond the drawing, okay? All right, number 18. Write the 3 ratios comparing AC to DF in 3 different ways. Okay, so AC is, what is that? AC is to DF. So let's fill that in. So we got 3 is to 6. Okay, so we got 3 is to 6, which is just 1/2, right? So how do you write a ratio? There's 3 different ways to write a ratio. Yep, Tobin?
50%.
Nope. How do you write a ratio? You could do it as a fraction. You could do it another way. Yeah.
You just look at there's like, I could be wrong, but there's like a colon.
Yep. So 1:2. All right, and then you could just say 1 to 2. All right, so there's the 3 different ways to write the ratio. Can you guys remember that? Spell it out, 1 to 2, or put a colon or a fraction. All right, find the area of the trapezoid. How do you find the area of a trapezoid? There's a couple different ways. This is not a rectangle. If it was a rectangle, you could just say base times height, like 28, right? But it's not. It's not 7 times 4. It's not 3 times 4. It's halfway between 3 and 7 times 4. So if I made this a little longer and this a little shorter, then I wouldn't sacrifice any area. So basically, it's the average of the bases times the height. That's the more complicated, tricky way to do it. So what would that be? 4.5? Or no, 5. Just 5 times 4, which is 20, right? The other way you could do it is make 2 triangles. How do you find the area of this triangle? 3 times 4 divided by 2, right? How do you find the area of this triangle? Base times height divided by 2. 7 times 4 divided by 2. That's 6. That is 14. And then add them together. 20 square centimeters. So if you forget the fancy way, the average of the bases times the height, then you can just break them up into 2 triangles and find the area of those 2 triangles. Okay? Can you guys do one of those 2 ways? All right, last but not least, number 20. Find the exact length of a hypotenuse of a 45, 45, 90 triangle with one leg of 8 centimeters. Okay, so this is a 45, 45. So how do you find that third side in a 45, 45, 90 triangle? You see why I put that other 8 there? Because it's a isosceles, right? You guys remember the shortcut? Anybody besides Tobin remember the shortcut? No? You don't have to. Okay, let's do it the long way. How do you do it the long way? Pythagorean Theorem, right?
What are we doing?
Trying to find this.
How?
So how do I set it up? Come on, guys. A squared plus B squared equals C squared.
Isn't there like a
There is a shortcut.
with the 2 8s?
Yeah, there's something to do with the 8. So 8's a part of your answer. But let's do it this way. 64 plus 64 equals C squared, right? 128 equals C squared. So C equals the square root of 128. How do you reduce this radical? Look for the biggest square that goes in there. You already know it. What's the biggest square that goes in there? 64. So this is the square root of 64 times the square root of 2, right? What's the square root of 64? 8. So your answer is 8 radical 2. The shortcut, just multiply by radical 2. So whatever number they give you there, just throw on a radical 2 and you got 100% for that problem. Can you remember that? Yeah. What is this third side? What's this? 5 radical 2. Can you guys remember that?
Yeah.
Okay, good. Done and done. Any questions with any of this test? There are 2 extra credit problems and there's a few extra credit parts to problems. So if you are struggling at all, watch the video. If you still can't figure it out, message me and we can talk through it.